So here's the standard KO4 turbo off an XR5 Focus or a Volvo C30 or many other models. If we have a look inside the outlet, exhaust outlet, you can see the wastegate and the turbine. Now if I zoom in and then pull on the, I'll just undo the actuator so it's easy. If I open that, you can see how the valve works. It's just a simple swing gate. Standard, the actuator sits about like that. There's actually a paint mark on the rod, so I can put it back to there pretty quickly. Looking at the turbo, okay, some of the things that some of the guys have concerns with, like boost solenoids or TCV, turbo control valve as we know it. This is the compressor inlet that your CAI connects to. This nipple here is basically just the return line or bleed line coming back from the boost solenoid. When we turn it over, this one here is on the compression side of the housing near the outlet, which goes down to the intercooler. So that is our pressure feed, which goes to the boost solenoid. Through the boost solenoid, via just pass through, then up to the actuator. So basically, when the turbo is operating, it's feeding boost to the actuator all the time, unless the ECU intervenes. And what happens is the ECU will energize the boost solenoid and it will open. But it's not just a simple valve, it's a bit like an injector, and it has a duty cycle. So it has actually quite fine control over it to a point. What happens is that it starts opening the solenoid and then allows boost to actually pressurize its way back to the inlet of the turbo, and this slows down the operation of the actuator opening and holds pressure up. But because that is the compressor inlet, it actually does suck against the solenoid as well, so it can bleed off boost very fast. The solenoid has to operate very quickly to try and control it, and the problem comes in when we have an aftermarket tune commanding high boost. The solenoid doesn't react quick enough to be able to control that properly. Now, having said those few things, that's your blow off valve, just this plastic piece of junk which we tend to replace with a decent forged one, or you can get an Elevate one now which is metal. It's simply a spring loaded piston basically, and it's just in the outlet. You can actually push it in with your finger if you go like that, but that port connects directly to the inlet manifold just behind the throttle body, so it actually receives boost pressure when the throttle's open, and it gets vacuum against it when the throttle's closed. This is a pressure differential because it's got pressure against the piston here in the outlet, and it could have pressure here or it could have vacuum here. Whoops, I'm not even showing it to you, am I? That's the blow off valve. The piston's just in from in there, in the outlet, pressure outlet. There's your connection that goes to the manifold. So you could have pressure or vacuum on there, but you'll always have pressure on there if the turbo's spinning. So it creates a differential across it, and that's how it's kind of a variable self-adjustment. Simply changing to an Elevate or a forge changes the threshold, the spring tension. allows it to hold boost pressure better. It won't leak. Now, for the actuator, which is what our main concern is here right now, I've actually got an IPD wastegate actuator adjuster tool. So you see here, I've got a gauge, a thumb valve, and what that does is it connects to a tyre for pressure. Now what we do to adjust these, I'll just zoom in on it. You disconnect your actuator, and with the thumb valve you can dial in some pressure to simulate boost. So you'll see there it starts moving. You can watch it and see when it starts opening, and as it opens it's holding more pressure. And that's at the end of its travel right now, fully open. But you can see with it fully open and pressure held on it, I can actually push that in with my hand. It's not very strong, and when I do that you can see it pushes the pressure up. The reason for aftermarket actuators is to have a harder spring tension in behind it, so it's harder for it to open again on itself, on its own. I've got a theory that it could actually push the wastegate open just via exhaust pressure, but I don't know if that's actually valid or not. Now, to adjust this, we basically have to decide what pressure we want to set it at. Now if I bleed it back down, the standard setting on these is 4.5 psi for our engine, and should be the same on a C30. So what we do is we dial in 4.5 psi of simulated boost. Which is a little bit difficult sometimes right on the low end. It's close. It's very fine adjustment. Anyway, that's around 5 psi, close enough. In fact, you'd probably want to set it about 5 psi. So, with that held at 5 psi, you would then do the actuator back up till it closes. And you can see it pulling the arm in when it closes. So basically I just want to have it done up just far enough so it doesn't actually open the rod further. Then when you do up the nut, with a spanner of course, when you release the pressure, the rod pulls back on the spring, and it's actually now firm. That is preload. The spring is preloaded. It takes 4.5 psi or 5 psi to actually be at a point where it can even open. That is now set perfectly for a standard car or any of the generic tunes. If we run an aftermarket one or have different ideas, we can change that. So from the standard setting, you could say let's give it half more turn of preload, then that might effectively make it start opening maybe 5.5 psi. This takes away some of the control of the ECU, makes it boost up harder, quicker, makes it wheel spin more, so the car can become a bit of a handful, very feisty. It's not really ideal, although it will hold slightly better boost. Only slightly, because it's only a stock actuator. The spring tension can be overcome easy. So there's your basic tool to adjust it, how to adjust it, and what to adjust it to. This is Uncle Chop Chop's workshop.